Good morning, everyone. Welcome back to Operation Management. Today we are going to discuss about the capacity planning, which is the last lesson before the midterm examination. First of all, I would like to give you the terminology of the capacity. Capacity means maximum rate of producing output or process input of the transformation system over some specified duration. So please remember that if we would like to talk about the capacity, we need to have the maximum rate and we need to uh, say something about the duration that it is given. The capacity issue could be applied to our organization, service, or manufacturing could be used this term. But the difference between services and the manufacturing company is that for the service provider, they cannot inventory the output. Therefore, they have to prepare for the capacity to be available to meet peak demand. So please look at this definition again. That is maximum rate of output or input over some time. Right? Okay. So here is the system. The first system is airline. I think the easiest one is this one. Okay, I will use this one. The automobile assembly plant. This is the manufacturing company, right? If we are talking about the plant, the factory output, maximum output to be produced, that is car, maximum number of car produced per month. Okay, you can see per month. Or if you want to measure in terms of the input, the capacity in terms of the input, we can looking at the index like delivery of part per day. That is maximum. For the university, okay, this is service system, right? The number of graduate per year. For instance, our university suppose that we can produce 10 maximum of 10,000 graduate per year. This is the output that we can produce, maximum output. Okay, don't forget the word maximum. If it doesn't say anything about maximum, it is not the capacity. If I just say that our university can produce this year, the university produced 5,000 graduate. It doesn't say anything about the maximum number of the output that could be produced. So in that case, number 5,000 is not count as the capacity of the system, right? Okay. If we talk about the input, don't forget the word again, maximum. Maximum number of students admitted per year. Okay. So here, another example that we can use is hospital. Hospital, maybe the output we may use the maximum number of babies delivered per month. Okay, don't forget maximum. In terms of input, the maximum number of patient admitted per week. Okay, time and maximum. All right, this is the capacity measurement. Don't forget the word maximum and over some specified period. And mostly the capacity, the measure of capacity may have many output in one system or in one organization. For instance, suppose we are talking about the hospital. In hospital, they may have many resources that um, are used in the hospital, like a bed, the number of bed, okay, the number of ambulance, and the number of parking space, the number of doctor, nurses, things like that. That is the resource that are used in one organization or in hospital. And one of them could be the bottlenecks. Okay, so we are going to discuss about the bottlenecks that are or that is the resource or resources which limit the organization normal operating capacity to something less than its desired capacity. Please look at this uh, line. Okay, this is flow chart line. Okay, you can see that raw material firstly come to machine A and then go to machine B and then C and then D and then E and come out as a finished good here. This one, machine C, is the bottleneck. Why? Because the production rate is the lowest. Okay, this one. You have 5 resources, but the one that limit the production rate or the productivity of the system, we call that one as bottlenecks of the system. Okay. One of the things that you have to know is about the yield, the definition of yield. Yield is an output of acceptable product comparing with the amount of input. So this is the formula for yield calculation. Like yield is equal to number of good output divided by the number of input. Okay, so it's supposed to be good output. For instance, suppose let uh, let me give you some example. Like the company wants 150 output, good output from the production system with 95% yield. What is the input? So according to the definition of yield, yield is equal to good output divided by input. It says that yield is equal to 95%. In that case, good output of 95 must come from the input of 100, right? This is definition of yield. So if you want 100 good output here, 100 good output must come from the input of 100 multiplied by 150 and divided by 95. That is the rule of 3 in arithmetics. And then you got this number 189 input. So you have to input, you have to put the input of 158 in order to get uh, 150 good output. The next definition about the capacity that you need to know is economy of scale. Please look at the graph. The graph divided by two parts is divided into two parts. Okay, this is the unit output cost, okay, unit cost of the output, and this is the capacity. You can see that from this graph, okay, you can see that this is the size of the factory, size from small, medium, and large. For the economy of scale, meaning that whenever you increase the capacity of the system, the unit cost will be decreased. Okay, the unit cost will be decreased. The unit cost of the product will be decreased. The more production, okay, the less per unit cost. But after this point onward, if you increase the capacity, because of the size of the factory may be too large. Okay, so you got confused, you got complex in terms of managing and control of the factory. So in that case, the unit cost of the product will be higher. This is what we call this economy of scale. Again, Economy of scale, whenever you increase the capacity, the unit cost of the product will be decreased. And this economy of scale, whenever you increase the capacity, the unit cost of the product will be increased, right? Okay, this economy of scale. Poor communication, long long line, or very hard to manage and control of the system, something like that. Why the unit cost is lower when you increase the capacity in the economy of scale? Suppose that is because the higher facility, the fixed cost will be shared with uh, large volume of product or services. For instance, suppose you have fixed cost of 100 baht. Okay, for this factory, the fixed cost is the overhead cost of 100 baht. If you produce 10 units, the share per item is 10, right? Okay, but if you produce 100 units, the share per item is equal to 1 per item. So more product that you produce, the per unit share of the fixed cost will be lower. And this is the reason why the more unit that you produce will give you lower unit cost, right? Because it could share the fixed cost for you. This is what we call economy of scale. The more you produce, the lower production cost will be achieved. Another concept that usually implement nowadays, okay, that is economy of scope. This concept is um, different from economy of scale because this concept focus on the flexibility of the system. The more system, the more variety that could be offered by the system will be more economy of scope or scope of production. Okay, variety of product or service offering. So fixed cost will be spread among more product or service. Suppose we compare between these two systems, System A and System B. System A can produce 3 products. System B can produce 7 products. System B is more economy of scope than System A. The number of variety that System B can produce is much more than System B. This is economy of scope concept. And we need to look at the what we call demand and life cycle for multiple product. If you look at the seasonal demand, okay, this is the sales and this is the period or the time, okay. So if the factory, if our factory produce air condition, this is the demand for air condition. So normally the demand for air condition is going to be high during the summertime, right? Okay, during summertime, the demand is high, and it will be low during the winter time here. Suppose your company produces kind of the product. This is the seasonal product demand or seasonal demand of the product, okay, for the air condition. You can see sometimes the demand is very high and in some period the demand is quite low. So in this case, if you just keeping on producing like this, so during the select time you do nothing and your facility will be utilized very little. It's not good. So you want something that utilize your capacity as stable as possible, right? You want something like this. So in this case, you need to find some product that is the anti-cyclic product. For instance, if you look at the air condition, you can produce during the slack period. Instead of producing air condition, you can produce heater, okay, or furnace like that, okay, so that the total demand will be stable. In that case, you need to find a reciprocal product demand or the anti-cyclic product to 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 work together so that the total demand, the total product demand or total production uh, facility could be used constantly. And the timing of capacity increment, okay, so we have four situation. The first one is small increment. This is the demand, and this is when you increase a little bit, okay, bit by bit here, right? Capacity. So in this case, if you increase the capacity in a small amount, um, the good thing of this approach is less risky, less investment, but challenge competition, right? But if you instead of using this tactic, if you use large capacity increment, this is the demand, and then you increase like this, okay? Increase the capacity significantly, okay? So risky, this approach, but can upgrade the entire production system. Risky because if you increase the capacity more than demand, and if the demand is not materialized, in this case, you will get excess capacity, right? Okay. The third approach is increase before the demand or preceding demand. This this approach is risky but enhance royalty because you have whenever customer come to see you, you can give them, right? Okay. You're always the one who always have the product for them. And if you increase the capacity following the demand, less risky, but encourage the competition, right? Okay, so it's up to you to select which one of the four approach that you can use. This is timing of capacity increment. Okay, so this is the last calculation question in your midterm examination. That is the bottlenecks in sequential operation or the flow shop operation. Suppose in our factory we produce the racket, tennis racket. Okay, this is the raw material come here, and the finished good is the racket. By using four workstation or four machine or four process. The first process is machine A, and framer, it is a framer, and it needs 4 minutes to complete the operation. That is the cycle time of this machine. Every 4 minutes, the part will pass to the next machine and then go to machine B. The cycle time of machine B is 3 minutes, and then go to machine C, and the cycle time of machine C is 10 minutes, and then go to machine D, and the cycle time of machine D is 2 minutes. Don't forget that the production rate is equal to 1 divided by the cycle time. In this case, 4 minutes you can produce 1 unit, right? So the production rate of this machine is 15 unit per hour. 15 unit per hour. which means 60 minutes per hour divided by 4. You got the production rate. In your exam, sometimes I give you the production rate and then you need to convert it into the cycle time. Here, for machine B, production rate is 20, machine C, production rate is 6, and machine D, production rate is 30. The machine which has the highest cycle time or the lowest production rate is the bottlenecks of the line of the system. Okay, we look at the whole system which consists of 4 machines here. So the bottlenecks here is machine C. And the production rate is controlled by the bottlenecks machine. Okay, in this case, the production rate is controlled by machine C, which is 6 units per hour here. And the throughput time is equal to 4 plus 3 plus 10 plus 2, which is 19 minutes without waiting time. Normally there will be a waiting time, right? But if there is no waiting time, in this case, the throughput time or the production lead time is 19 minutes. Or minimum time to produce the product is 19 minutes. Okay, minimum lead time of the system according to the information that is given to you is 19. So here C is bottlenecks. So the efficiency of the line, okay, is equal to output divided by input. The output is always constant. The summation of the cycle time, that is 4 plus 3 plus 10 plus 2, come from this one. Okay, 4 plus 3 plus 10 plus 2, the output. And then the input is equal to number of machine that is used in the system and multiply by the cycle time of the bottlenecks. In this case, the number of the machine is 4 and the cycle time of the bottlenecks is 10, right? Number of machine is 4, 1, 2, 3, and 4. And the cycle time of the bottlenecks is 10. So in this case here, the efficiency of the line is equal to 47.5%. If we want to increase the capacity, the production capacity of the line, what should we do? We should add the machine. We should add the machine to the bottlenecks machine by parallel it. Right? Okay. So at the beginning we have 4 machines. If we want to increase the capacity of the line, we need to buy one more machine C. Okay. Bottlenecks is C. The cycle time is 10. Production rate is 6 units per hour. Efficiency is equal to 47.5%. So the action that you have to do whenever you want to increase the production rate is add one machine C to the line. Okay, so when you add machine C to the line here, by parallel machine C together. So in this case, the equivalent cycle time will be equal to 5 because you got 2 machine C. Within 10 minutes, you can produce 2 units. Okay, so the time that you need to produce 1 unit is equal to 10 divided by 2, which is 5, and this is the equivalent cycle time of 5. So now you have machine A 4, cycle time of machine A 4, B 3, C 5, D 2, right? Which one will you add? Again, the bottleneck is machine C still. Okay, So the cycle time now is 5. The cycle time now is 5, right? Production rate after you increase one of machine C will be 60 divided by 5, which is 12 units per hour. And the efficiency is equal to output divided by input. The output always constant, okay? 4 plus 3 plus 10 plus 2, the same. Divide by how many machine? 5, 1, 2, 3, 4, 5. And the cycle time of the system, that is 5. So efficiency increased to 76%. Then if you want to increase more production rate, now the bottleneck is still machine C, right? Bottleneck is C. So you need to add one more C. And when you add one more C, right? The equivalent cycle time of machine C is 10 divided by 3, which is 3.3. Now, the bottleneck is moving from C to A. Bottleneck is here, right? Okay, because this is the longest cycle time. 4, 3, 3.3, and 2. This is the highest one. The cycle time now is 4, and the production rate is 60 divided by 4, which is 15 units per hour. And the efficiency is output the same as the previous one, and the number of machine is increased from 5 to 6, and the cycle time is 4. So the efficiency is 79.2%. And again, if you want to increase more production rate, you need to add the bottleneck machine. And at this time, the bottleneck is machine A. You need to add one more A here. Then the equivalent cycle time of machine A is 2 because 4, 4, 4 divided by 2, which is 2. Now the bottlenecks, this is 2, 3, 3.3, and 2. The bottlenecks is moving to here because this one is the highest. So the cycle time of the line now is 3.3. The production rate is 60 divided by 3.3, which is 18 units per hour. And the efficiency is 4 plus 3 plus 10 plus 2 divided by the number of machine, which is 7, multiplied by the cycle time, which is 3.3, that is 81.4%. Action, if needed, is at machine C. You can continue this until the end, until whatever you want, okay? Okay, that's end for the presentation. And your last assignment here, okay? I give you the same problem. The 4 machine, I give you the cycle time of each machine, but I change a little bit about the way we produce, we make the decision. Suppose that each machine costs, the cost of each machine is given, like A costs 50 per machine, B 20, C 10, D 75. You got the budget of 200 to add machine to this system. Okay, additional machine. Okay, this is the current system. Okay, you got 200 baht available to buy a new machine. So how many machine that you can buy and what kind of machine that you can buy? Don't forget, first of all, you need to find the bottlenecks of the machine, right? And then you add that one, and whenever the money is not enough to buy the machine, you stop, right? Okay. So the question is, what machine and how many of them will you buy? What is the maximum production rate that you can achieve by given budget? At the new maximum production rate, what is the new cycle time of the line and what is the new efficiency of the line? All right. So you need to do like this here, starting from this picture and then continue like this. Okay. You don't have to prepare the table. You don't have to prepare the table. No need for this table. You just follow just this one, this one, this one, like that. Okay. So I hope that you can enjoy the exercise. And if you need any help, and as I told you, this is the last assignment before the midterm examination. And in the next section, I will give you the hint about what is going to be appear in your midterm examination. Okay, if you need any help with your assignment, please ask Pitan or come to see me in my office. Thank you very much for your attention.